In this video, I'd be talking about servlets and JSPs. Servlets and JSPs need what is called a container, not just a web server. The container is used by the web server when web server gets dynamic requests from the client. Okay, so consider this block diagram in which the client is sending a request for a dynamic web page to a web server, and the web server forwards the request along with the parameters to a web container, and the web container would would pass the same parameters to a servlet, which is Java code, and collects the response from the servlet and passes it on to the web server app, which in turn forwards the response to the client that made the request. So these are the benefits of using a container. The container can communicate with the container knows how to communicate with the web server, and it manages the lifecycle of the servlets and JSP pages. It also has multi-threading support, so for every request to a servlet, it spawns a thread to run the servlet code. And you could declaratively provide security parameters to a servlet by within the descriptor file, which is web.xml file, and it also converts JSP to Java code, so that so it takes care of all the necessary coding, which lets you concentrate more on your own business logic instead of worrying about writing code for threading, security, and networking, and so on. Let's take a look at what container does to handle a request. Basically this server receives a request and forwards the request to the container. The container then creates a request object and a response object and passes these two objects to us to a servlet. But before that, it actually creates, after creating request and response objects, it creates or allocates a thread for that request and passes the request and response objects to the servlet thread. And after passing the request and response to the servlet thread, it invokes the service method of the servlet. So depending on the type of request that the client has sent to the server, the service method calls either toGet or toPost. So the service would call toGet in this example, and the toGet would stuff the page into response object. So the toGet would generate HTML and stuff HTML into the response object and pass it back to the container. Now the thread completes after sending the response. The container converts the response object into an HTTP response and sends it back to the client, then deletes the request and response objects, as well as the thread for the servlet is cleared. So the servlet hands over the response object to the container, and the container would convert the response object to HTML and send it back send back the response to the client. So this is what a servlet looks like. CH2 servlet is a servlet because it extends HTTP servlet. What you could notice here is that there is no main method in the servlet, and the servlet's lifecycle methods like toGet are called by the container, and the servlet is actually invoked by the container, so there is no explicit main method for a servlet. This is where your servlet gets references to request and response objects which the container creates. So request and response objects are sent to the servlet by the container. So let's take a look at the deployment descriptor that goes into a web project, into the web.xml file. So the servlet is a tag which maps internal name to fully qualified class name, and the servlet mapping which maps internal name to public URL. So this is the servlet tag within web.xml file, and servlet has two tags: servlet name, servlet class, and servlet mapping has servlet name and URL pattern. So so this is what is generally seen by the user, and when a request is made to public 1, then it would go look at internal name 1 and find foo.servlet2. Okay, this is a fully qualified name of a class which serves the request sent to public 1. So what servlet tag does is it maps internal name to so this is internal name. It's mapping the internal name to fully qualified name, whereas this one is mapping the internal name to the public URL name. So internal name 1 and internal name 1. So any request sent to public 1 would be mapped to foo.servlet1, and any request sent to public 2 is mapped to foo.servlet2 because of internal name 2 here and internal name 2 here. Okay. So what are the benefits of deployment descriptor? It first of all minimizes touching source code that has already been tested, and it lets you fine-tune your application's capabilities even if you don't have the source code, and you don't necessarily have to be a programmer to be able to modify a deployment descriptor, and it makes it easier for you to maintain dynamic security info like access control lists and security roles. So all you have to do is to modify the deployment descriptor to configure the way of accessing your servlets and providing security and other parameters for your servlets. Let's take a look at an example. So in which you're trying to build an application and which involves database access, and then you have a servlet and a JSP page. Sorry, no. Okay. You have a servlet which does the business logic, that is accessing the database as well as printing the HTML. So all of the business logic and the client HTML page response is inside the servlet code. This is not a good design. Okay, now you could sort of decouple the view, which is the HTML part, from the business logic part, and you could do something like this in which you have the business logic within the servlet, and after you're done with the business, after you're done processing the code that contains the business logic, you forward the request to a specific JSP page instead of trying to print the HTML to the output stream from within the servlet. So every servlet contains only the business logic, and it forwards the request after processing the business logic to a JSP that contains the view. So this is how transaction looks like. You send a query, the web server forwards it to the container, which would invoke a specific servlet, and which interacts with the database and generate results, and gives it back to the container. The container sends it back to the server and then forwards the response to the client. Okay, so what should be noticed is that the servlet is processing business logic, as whereas the JSP contains the response HTML, that is just a view. So each servlet runs its own business logic and then invokes a specific JSP to handle the HTML for the response, separating business logic from presentation. Let's take a look at so this is the model view controller. Takes the business logic out of the servlet and puts it in a model, a reusable plain old Java class. So if I were to later change the interface, instead of having to use servlets, if I want to use swings and still want to make sure that the application works, then it's better that you separate the model, which is the business logic, and put it in a model, that is, put it as a separate Java class, so that you have this servlet. So if I were to say, for example, later on use swings, I could easily make use of the Java classes, which otherwise wouldn't be possible if I were to have the model within the servlet code, in which case I'd be bound to use the servlets in order to make this application work. So the model is a combination of business data and the methods that operate on that data. So I have a view, which is the interface, and which sends a request to the servlet, and which forwards the request to the model, so that the model can operate on the state of the system, which is operate on the database. It has rules which defines the way it should interact with the database and modify the state of the system. And then after it's done, it would send the results to the servlet, which would forward it to to the view, and which in turn forwards the view to the browser. So then if you were to use MVC pattern for the previous example, the original servlet will be the controller, the new business logic class will be in the model, and the JSP will be in the view. So J2W application servers can contain both web containers and EJB containers, as well as JNDI and JMS, whereas Tomcat is just a web container but not a full J2W application server. So this is what a J2 application server comprises of. Okay, so let's take a look at a simple example. My web browser has sent a request to xyz.com/ch1/myserv. This is xyz.com server machine, and Apache web server is running on 80. So it takes a request and forwards a request to Tomcat, on which my servlets have been deployed. In this way, in web apps, I have ch1. And then ch1 in turn has web-inf, which has the deployment descriptor web.xml, and ch1 has and it also has classes, in which I have servlet.class. Now my serv here is mapped to servlet in the web.xml deployment descriptor, which is right. So the servlet is nothing but the servlet.class within the classes directory, and then once this is found, the web container would go about creating the request and response objects and creating a thread and so on, which has already been discussed in this video.